So this is my first lab for physics 2211 and by Mariana Robles. Today basically we're going to talk about Newton's second law and how it connects to the lab we were doing. And I'm going to show the video that we did within the lab, the Python code that we did and how I changed it so it can fit the parameters of the lab, and then the graph that I created using the info we got from the tracker video and the Python code, and then the what if scenarios. Firstly, when looking at Newton's second law, we need to take into account that it's derived from the position formula, and then it's derived for velocity update formula, and then we have the acceleration update formula. Here we're just going to be looking at the momentum formula, dp over dt, and how it connects with F net, the forces involved, and the time that it took the marker go from its initial position to the final position. Um, this is the video that we took within the lab. And here I am just taking back the video, and I'm plotting each point in the intervals that started there. The marker starts moving when it leaves the person's hand, and then I track all the points that it hits across the table. And then once it reaches its final position, I stop the points, and that's where the graph reaches its peak. With this, trying here to exit out of it. With this, we changed the original code we had done for a ball that is moving, for in this case it's a marker. We took its initial position. If you notice what's colored in red, basically that's every point that I changed. For 0.2561 in the first box, that's the initial position that I gathered from the video, and then the 0.067 is basically the change in time that it was taken, from the original time to the final time, which, if you notice in the third box, is 2.78 seconds, how long the video actually is. And then we compared the two graphs that were created, one from the tracker video, those are the points that I got. And then the second line is the points and the information I got from the actual code that I did. And you notice the blue line on those points, eh, those are the actual values. Those that has a curve because of the air friction, that the friction and the different forces that we had to take into account, and that's why it's going down, it's slowing down. And then for the what if scenarios, we had to ask ourselves, what if you changed to a negative axis? Basically, that would mean that the velocity would become negative, because it would be the graph would be going in the negative direction. Yet, when you're plugging into the momentum update formula, it stays positive because we're taking its absolute value. In that case, it can be negative. Also, we need to take into account, we're asking ourselves, what if the net force is zero? If the net force were zero, that would mean that we wouldn't be taking into account the air resistance, friction, the gravity that is going onto the marker, which isn't possible unless we were in a vacuum, I guess. Another question we need to ask ourselves, is there a way to calculate how many net forces are acting on the marker? I believe that this is impossible because there's so much going on and so much that it's impossible to calculate all those forces. In this case, the system is the marker and the surroundings are all the forces, aka the air resistance, the friction, the gravity, in total. And for that, there's two, besides those forces, we can't really determine which other ones could be acting on it. Thank you so much.